Hi, ladies and gentlemen. It's Mr. Green again, and it's time for another one of my series in geometry lessons. I appreciate you being here and listening to this. We should all be finishing up Unit 4. If you're not already finished with it, you should be getting really close to getting finished with Unit 4. We're continuing to work on Unit 5. We are approaching the end of the semester, so you need to make certain that you are getting this stuff done. Don't forget, you can make corrections to things that are failing grades. We want to keep our grades as high as we can. Due dates, we're letting things slip a little bit. If we don't get them taken care of, they will start being permanent zeros in our grade book. We want to make certain we get that taken care of. Okay, where are we? We are to the point of talking about the Pythagorean theorem. The Pythagorean theorem is something you've studied in past math courses and things like that. You should all recognize it as a squared plus b squared equals c squared. It is simply the relationship between the sides of a right triangle. See how it's a right triangle? We're looking at the sides of these right triangles. Now, I always get asked this. Does it make a difference which one is A and which one is B? No. The only one that is really important that you know which one it is C. C is the hypotenuse. It's always the one that is opposite the right angle. Okay? So you're always looking for that hypotenuse. And no, it's not a hypotenuse. It is a hypotenuse. Okay? So we're looking at finding any one of these missing values using the Pythagorean theorem. How do we find those? Well, if we're given a value over here for side AB, we can simply square that. If we're given a value for side B, or this value right down here, BC, we can simply stick that in and square it. And then that's going to be equal to the third side, AC squared. How would this look in a real life problem though? Okay? Didn't give me one. Let's go back to it. What if I told you that this side was 10 and this side was 12? Could you find the third side here? Sure. All you have to do is plug the values in to the formula and work through it. 10 squared plus 12 squared. Well, that's 100 plus 144. That's 244. And that's equal to AC squared. Well, one of the tricks we know in algebra is the opposite of squaring is the square root. Okay? And so we take the square root of both sides of that equation, and we get that AC is equal to the square root of 244. Now, in algebra, we go through a process of finding how to find that and what to do with that information. But in geometry, we just use our calculator and key it in real quickly, and we get that 15.6 is approximately equal to AC. Okay? So let's talk about an application of this. When is this used? You know, in construction, they use this all the time. They'll nail some boards together, and they're trying to make a window. They'll make certain they nail all the boards together to make the window, and then they will measure up one side, and they'll measure up another side, and they make marks at both of those locations, and then they measure the distance between them, those marks. What does that do for us? Well, if we know certain values that make right triangles, we will have values that fit into this example. Construction people always use a 3, 4, 5 right triangle, because if I make this side 3 and this side 4, this side will be 5. Okay? And they can all just measure it and make certain that they have 90-degree angles. That is what is important when using the Pythagorean theorem. That's where it's used from. Okay? Now, where did it come from? Let's go back to the ancient Greeks. Okay? The ancient Greeks used this formula to help them decide how far, well, they knew how far they could throw a rock with a catapult, and they would simply measure where they were and where the ship was out at sea. They couldn't measure that distance, but they could measure down the beach a little bit to here, and they would look at this angle, okay? And they would say, okay, if we've got a certain angle here, we know what that distance is. And so they would look to see when the ship was at that angle, and they'd fire their catapult to hit the ship. Now, there were lots of inaccuracies and lots of problems with it, but it was one way that they were able to use the Pythagorean theorem to help them get someplace. Now, what is the converse of the Pythagorean theorem? The converse of the Pythagorean theorem says that if I have this equation working, then I have a right triangle. Okay? Now, we've spent a lot of time talking about the theorems and their converses. Converses are things which you're getting information that you might not have been able to figure out the other way. Okay? Make certain that you always look at the converse of the Pythagorean theorem to know what's going on. Here, what we're looking at is we've got some side lengths, and they want to know, is it a right triangle, an acute angle, or an obtuse triangle? And you know what? That is an offshoot of this converse of the Pythagorean theorem. Why? Pythagorean theorem says if it fits and they're equal, then we have a right triangle. If they're not equal, then we might have either an obtuse or an acute triangle, right? So how do we determine whether it is an acute triangle or an obtuse triangle? And what I'm doing is I'm turning them in the book. And you know what? I know you all got books. Remember them? Those are those things that have the balloon on the outside of it and it says geometry. If you turn in your books to page 158, on page 158 it talks about the Pythagorean inequalities. And it's just a little paragraph. It's not a lot. And it simply says that if they're equal, you've got a right triangle. If c squared is bigger, then you have an obtuse. If c squared is smaller, you've got an acute. That's interesting. So if we look at a problem like this, which is my c squared? Well, that's this one right here, 50. So all I've got to do is pause while I start the calculator. Okay, got my calculator up here and running. So all I've got to do is say, well, 50 squared is this button right here. Hit enter. I'm now going to take 14 squared plus 48 squared, and I'm going to get the same thing. See how they're equal? That means that this must be a right triangle. Okay, that makes sense, Mr. Green. What about the next one? Well, 8's the big one. That'll be the C, right? So if I take that and I say, well, 8 squared, I know that one. That one's 64, right? And I take 4 squared, that's 16, plus 4 squared, that's 16 again, that's 32. My C squared is bigger. That must mean that I have an obtuse triangle. Why? Because if the c squared is the bigger number, it's obtuse. See how I'm using that information? Okay? On this one, 15 is your c squared number, is your c, because that's your biggest number, right? So 15 squared equals 225. And then I've got 7 squared, that's 49, plus 14 squared, and that's equal to 245. So c squared is the smaller number. So that would be an acute triangle. Okay? Does it work with partial fractional numbers? Yes, it does. Let's try this one. Which is the biggest number? 6.5. That's going to be my c squared number. So I'm going to take 6.5 squared, and I'm going to get 42 1/4. Oops, go away. Can't talk to you right now. Okay? And I'm going to take 2.5 squared plus 6 squared. And what am I going to get? 42 1/4. So that one is a right triangle. Do you see how I'm using this information to find out if I have a right triangle, an acute triangle, or an obtuse triangle? Important information to know. Okay? Now, we're going to jump right from looking at that into some very special right triangles. Okay? Why are they special? Because quite honestly, I'm lazy. And most mathematicians are. I would rather memorize a fact rather than figure it out every single time. And if I've got a 45, 45, 90 triangle, that means this side is A and this side is A. I don't need to go through the Pythagorean theorem every time. I know that this side over here is going to be the square root of 2 times A. And it is easier for me to multiply it than it is to go through the Pythagorean theorem every single time. And if that makes it just easier for us to calculate these values. It makes it a little bit quicker. Who wants to spend a lot of extra time calculating some stuff? Not me. I'm lazy. Okay? So let's look at another one. The other one is the 30, 60, 90 triangle. How do I remember it? Well, 30 plus 60 is 90. We expected that, but you also notice that this is 1/3, 2/3, and 3/3. Guess what? It's the most common one that you'll find in nature a lot of times. It's a 30, 60, 90 triangle. Well, we know that the biggest angle, this one, opposite the biggest side. We know that the next biggest angle is opposite the next biggest side, and the smallest angle is opposite the shortest side. But there's a relationship between these sides. And the way it works is, this is the shortest side. The hypotenuse is always 2 times bigger. 2 times. 2 times bigger. This one over here is the square root of 3 times that shortest side. So x times the square root of 3. That's the relationship between these sides. It makes it easy. If I've got a 30, 60, 90 triangle, I always know that this is the relationship. And I don't have to go spending a lot of time using the Pythagorean theorem to figure it out. How does that help me? How does all that help me? Well, looking at this triangle right here, I see a 45-degree angle right there. That means this one's a 45-degree angle. That means this side over here is 12. And I can look at C right here, and I know for a fact it's going to be the square root of 2 times 12. And that's all I had to do. I didn't have to go through the Pythagorean theorem to work it all out. Okay? All I had to do was to write that down. That's how you find this information. You can see how it will help you solve problems much quicker if you can memorize that information. Okay? Now, here's a hint. This information, get it to work for me here. There it goes. This information is on the formula chart for the STAR test. This information is on the formula chart for the STAR test. I know there's not a STAR test for geometry any longer, but if that information is on that formula chart, it tells you that it's something that a lot of mathematicians use. It helps you solve problems quickly. It is useful information, okay? You will see this in nature. You will see this in many different types of shapes, okay? Having said that, final problem I'm going to work with you here. We've got x and y, 2 different values that we're trying to find. I can see that this is a 45, 45, 90 triangle and that this is 10. I'm going to take 10 divided by the square root of 2. And that's going to tell me what side x and y are. And they're the same values. So it's not going to be hard to do. Wow. Makes it easy to find those answers. Quick. I lied. We're going to work one more problem here. I'm seeing a square, right? And they're wanting to know what? They're wanting to know the lengths of the sides. So we're going to have to find that diagonal right there. Okay? And what do we know about this? Not much. But I can figure it out. I can figure out that this diagonal is x times the square root of 2. That's all I needed to know about that, okay? Now what they are telling you is that in a word problem, if we said that this diagonal was equal to 12, I could find what x is simply by taking 12 and dividing it by the square root of 2. And we could find the length of the sides. Where does this come into play? You know what? There's a lot of televisions that are advertised that are square televisions. They say, well, they're a 12-inch television. That's 12-inch diagonal. And if you take 12 divided by the square root of 2, you get 8.5 inches. So it's only 8.5 inches wide on every side. Okay? Let's look at this one. I want to show you how a 30, 60, 90 triangle works here. Okay? So I've got this 30, 60, 90 triangle. 30, 60. That means this must be a 90-degree angle right here. This side over here is listed at 6. I know the hypotenuse is going to be 12. 2 times that number. I know this one down here is going to be 6 times the square root of 3. I'm not having to use Pythagorean theorem to do it. All I'm having to do is solve it using those values that I knew existed. You see how I'm doing that? It's kind of fast, but that's the reason that we're wanting to have these, so that we can be faster at solving these type of problems. Okay? So 30, 60, this side over here is 12. Well, 12 must be equal to the square root of 3 times the smallest side, y. So if I take 12 divided by the square root of 3, that's what y is going to be. And this side over here is going to be 24 divided by the square root of 3, or 2 times what y was. And that's all I had to do to figure these out. Okay? And you can see down here, they did 12 divided by the square root of 3 and got this 6.94, and then multiplied it times 2 to get that 13. I'm just leaving them in those square root methods. Okay? Couple more here. Let's see here. 30, 60, 90 triangle. And they're giving me that the hypotenuse is 9. I know this one is going to be 4.5. Why? Because it's half of the hypotenuse. And this one's going to be 4.5 times the square root of 3. Okay? Square root of 3 times 4.5. Now, I know some people are asking me, how do you have those memorized? Well, it's not that hard. If you're looking at a 45-45 triangle, I've got 2 sides the same, so I'm going to use the square root of 2. If I'm looking at a 30, 60, 90, those are all multiples of 3, so I'm going to use the square root of 3. And then it becomes really easy for me to remember which one I'm using and how to use those values. It will be something that you can simply figure out. Okay? You know what? A lot of people say, but there's a lot of triangles that are equilateral triangles, just like that one. And you're right, there are. What I do with an equilateral triangle is I almost always divide it in half, making a 30, 60, 90 triangle. And if this side was 8, this side down here was 8, that means each portion down here was 4, and this height is 4 square roots of 3. If I've got 4 square roots of 3, that's the apothem in some situations, or the height of that triangle. I can then find out the entire area of that triangle by simply multiplying it out. But what we were trying to find here was the height, and that's what we found, 4 square roots of 3. That's what it says right here. Got to have a pointer. 4 square roots of 3. And they just multiplied it out to get that number. Cool? Cool. I appreciate you guys telling me that you're all in geometry when you send me information. It helps me find your records quickly and answer your questions. And I don't like you all waiting to get your answers. So if you have any questions, feel free to come to Toga or send me K-mails. Let me know what your questions are. I'll be trying to get you quick answers. I'll look forward to seeing you next time.